So this is Karen O'Brien, and we have just worked up through step 9 in the previous video, and now we're going to continue on to finishing up the channel and then running the simulation. Then there will be a review video that's already in place. As you can see, if I just go here, you can see that there's a channel review video. And then the final video will be to do a trap channel instead of an end channel. So I'm going to go back to channel boundary, and we're just going to follow these steps to assign the upstream and downstream boundary conditions for this channel and the culverts, and then export the data and run the simulation. So let's go ahead with that now. Okay, so let's go ahead with the boundary conditions. So first off, I will get this stuff closed up because we're done with it for now. Whoops, like I said, we're done with it. Go to the boundary condition editor and grab a point and then zoom in to the beginning of the channel. Now, I no longer need the user layer, so I want to turn those off. That's important because I only want to deal with the schema data. So I want to put my inflow node on the first cell because the inflow hydrograph is going to be assigned to this cross section. Yes, it's an inflow, so I click OK. And now I want to do the same thing except down on the downstream side of the channel. This one is the downstream boundary. Again, it's an outflow node now, but again, it's assigned to the whole cross section. Then I click Save and OK, and I need to finish those two boundary conditions. So if I go to the inflow, you see here that it's automatically been assigned to the Grover time series, so that's wrong. So we need to fix that. We need to tell it that is a channel node, and we need to name it. Let's start by naming it. This is the Greenway in, and it is a channel inflow node, and it needs a new time series. So that button is right here. Click Add a new time series. Back in lesson 2, there is this guy, the Greenway inflow node. Control A, C, W. All keep that control button down. Control A, C, W. Then we come back over to our table, select the very first cell and click paste. And that is our new hydrograph for that channel. Time on the left in hours, discharge on the right in cubic feet per second, because this is not a metric model, and there's no mud flow, it's just clear water. Let's go ahead and name that. This will be called the Greenway 100-year 24-hour hydrograph. Now let's switch over to the outflow side of the table, and outflow number 1, let's go ahead and name that Greenway out, and give that a normal depth discharge configuration assigned to the floodplain and the channel. So remember, the normal depth is assigned to this cross section and also to these bank elements on the left and right side. Now, once that's finished, we hit the final thing to do is to schematize it. So hit the schematize button so that you can then see that you now have your little blue schema button. And we'll take that back over to the Greenway, and you have your little green. And if you went up to Grover, you'd see that you still had your Grover inflow condition too. So we're now finished with that. Let's go ahead and go back to the next steps in the tutorial, which are to add our culverts. Okay, so culverts connect channels to channels, right? So if I go to my structure editor, I'm only going to be doing left bank to left bank. So I'm going click, left click, right click. Again, I click this guy right here, and it's left click, right click in the flow direction. So I know my flow direction is from this side of the screen over to the west, east to west. If you don't know what your flow direction is, you can use a profile tool to determine the flow direction, or you can review your channel. But typically you know this. Sometimes it's not as obvious if you're on a floodplain. Go down and get the other one, same thing. Left bank has to be that left bank because it's assigned to that cross section, right? Left bank, right bank, okay, save, and then I can start naming them and defining there. So hit center, go to structure 1 and start filling out the table, okay? So it's green, capital GRNWAY 1. That's very important. It is a channel to channel. So this cross section is feeding this cross section. It is a rating table and no tailwater effect, and all these are zeros. Next one, Greenway 2. Channel to channel, rating table, everything else stays in the default position. Their tailwater effect, not much of a tailwater effect on these because they have this great big drop structure right after the channel. So we just leave that alone. And then we go with the import rating tables and see how the names are capitalized. That's why I had to capitalize these guys here. Select both of the tables, click open, and now if I reselect one of these, you'll see the rating table. So important thing for channel rating tables, you need to define the transition between your cross sections, which we did a pretty good job of. And as the water comes down through these cross sections and hits this last cross section, this very last cross section is water is going to hit that at 0.1 feet of depth, and 2 cubic feet per second is going to be moved to the downstream node. So the invert of this cross section is the invert of the culvert. All right, let's go ahead and click Schematize, and that will define the blue line, which is the schema data. And then this structure is complete. We now need to set up, make sure that these are right, 24-hour simulation, point 1 text screen. Don't need that. That's set to English. The limiting fluid number is applied. The shallow end is applied. The depressed depth is applied. We got rainfall, infiltration switches are on. We have a main channel, and we have hydraulic structures. We don't have any time series output data. Now, since we added a channel, we also have now a channel courant. This grid cell size is 30 by 30 feet. So I don't really need to mess with my courant number unless my channel gets super steep, which it isn't. It's pretty relatively flat channel. If your grid element size is really small and your channel is relatively steep, has a relatively high slope to grid element size ratio, then this number may need to go down because this number is going to control the time step so that the water that flows, let me get from this cross section to this cross section doesn't overshoot the cross section because of the velocity. So the time step will be, if the time step is too high, then the discharge will pass the next cross section downstream, and we want it to be aligned properly. So the courant number will make the adjustment to the time step so that that happens. So if this channel is very stable because it's a 30-foot model, but if you get down to a smaller and smaller grid cell size, that's a shorter distance between your channel cross sections. So if you're down to 15 feet or 10 feet, you might see that you have some instability in your channel data. But if you come back in here to your courant number, you can start dropping that down. Sometimes you have to drop it down to 0.4, sometimes 0.3, sometimes you even have to drop that down to 0.2 to stabilize your channel. So that's one of the reasons we really don't like going below 20-foot cell size when we're doing urban channels, okay? So I'm going to leave it at 0.6 because I'm using a 30-foot by 30-foot cell, and this is not a super steep channel. All right, now let's go ahead and export the data and then run the model. So this goes into Lesson 2 Advanced Export, and we have channels, outflow nodes, inflow nodes, rain infiltration, hydraulic structures, and manning. Click OK. See, you got all those files. Click OK. Go here to your export, and I have, this is old. It's not supposed to be in there. Actually, let me just, sorry about that. Let me try that one more time. I'm just going to export that again because I didn't want all that stuff to be in there. So export, select, okay, and now we can either run it from here using the run button, or if you already have your engine in here, you can run it from here. This is the new engine. I'm testing it. There are no data files in this folder. Hang on. Did I put those in the wrong folder? It's a new engine, so of course, no, yeah, it's definitely put those in the wrong spot. Oh, that's why. Sorry. It's here. Yeah, I was gonna say, I thought I did that right. And professional, you can tell I'm activated because you get the blue screen, and just wait for the time and then just let it run. And the next video will be to review this channel. So I'm going to let it run and stop this video, and the next video we'll pick it up when we do the channel review.